Introduction to proofs. Proofs all start out with a goal, what it is we are trying to prove. A proof is not open-ended exploration, but is directed towards a specific end. The goal is to find a logical path using true statements along the way that leads to what we are trying to prove. We know the last statement of every proof when we start. It is what we are trying to prove. Geometric proof is based on a deductive structure, a system of thought in which statements are justified by reasons of previously assumed or proven statements. The deductive structure of a proof contains the following 5 elements: given information, assumptions from postulates and from drawings, definitions, algebraic and congruence properties, theorems, and other conclusions, corollaries. A two-column proof is a style of presenting a deductive argument that proves a geometric theorem or a mathematical statement. The first column is devoted to statements and the second column to reasons. Here are some important algebraic properties that we will need as we write proofs. These will be used as reasons in two-column proofs. The algebraic properties, here, a, b, and c are numbers, c is not equal to 0. So we have the addition property of equality. If a equals b, then a plus c equals b plus c. Subtraction property of equality. If a equals b, then a minus c equals b minus c. Multiplication property of equality. If a equals b, then a times c equals b times c. The division property of equality. If a equals b, then a divided by c equals b divided by c. Reflexive property of equality. A equals a. Symmetric property of equality. If a equals b, then b equals a. Transitive property of equality. If a equals b and b equals c, then a equals c. Substitution property. If a equals b, then b can be substituted for a in any expression or equation. In the first column are statements, and in the second column, reasons. The first column are the steps you would take to solve the equation. The second column is the algebraic justification for each step along the way. So we begin with our given statement here, 3x plus 2 equals 14, and we're going to be ending with x equals 4, which is what we're trying to prove. So when we start with here, this is the given, 3x plus 2 equals 14. Then we subtract 2 from both sides of the equation. Because of the subtraction property of equality, we are left with 3x equals 12. Then we divide both sides of the equation by 3 because of the division property of equality, and that leaves us with x equals 4, which is what we were trying to prove. Note, the first step of this proof is typically the given statement. The last step of this proof is what you set out to prove. L-shaped reasoning. The two-column proof is a deductive structure. Each step is deduced from previously stated truths with reasons as justification. So given that 3x plus 2 equals 14, prove x equals 4. I know that 3x plus 2 equals 14. It's given. It follows that 3x equals 12. And here's why. The subtraction property of equality. Then the next step, it follows that x equals 4. And here's why. Division property of equality. So you can see we have our statements and our reasons, just like this. The same example can also be written as a flow proof. It has all of the elements of the two-column proof, but statements and reasons are organized in a different way. Here we do start with the given, and we end up with what we're trying to prove, but we move to the right using arrows. A two-column proof can be used to prove an important idea in geometry. Let's prove that vertical angles are congruent. Given line segment EC and line segment AD intersect at B, prove that angle 1 here is congruent to angle 3 here. Alright, so we begin with what is given. Line segment EC and line segment AC intersect at B. Alright, next step. The measure of angle 1 here plus the measure of angle 2 here equals 180 degrees, because that is the angle addition postulate. Also, the next step would be the measure of angle 3 plus the angle of measure 2 is also equal to 180 degrees because of the angle addition postulate. Because here we have a line, so those two angles there add up to 180, and these two angles here also add up to 180 because of this line. All right, so therefore, the measurement of angle 1 plus the measurement of angle 2 equals the measurement of angle 3 plus the measurement of angle 2 because of the transitive property. Because if both of these equal 180 and these equal 180, then you can set these two things equal to each other. All right, and when you cancel out the measure of angle 2, because of subtraction property of equality, so we'll subtract that from each side, we get that the measure of angle 1 equals the measure of angle 3. Therefore, angle 1 is congruent to angle 3 because of the definition of congruent angles.